Hi, in this video I'm going to take a look at endothermic and exothermic graphs. First, let's draw an endothermic graph. And an endothermic graph would look like this. Over here, this is potential energy. And down here is time. So as time increases, the energy goes like this in endothermic reaction. Over here, this is product. This is reactant. This point is called the activation energy, which we'll say EA. And then from here to here, this point marks EA prime. And then from this line to this line, this part is what we call delta H. Now, an endothermic, EA stands for activation energy, which is the amount of energy needed to get a reaction started. Now, our EA prime is the reverse activation. And that is the amount of energy needed for products to become reactants again. Now, delta H is the change in heat during a reaction, usually measured in kJ. Delta H is equal to the product minus the reactant, which in this case is the, this should be an R, which is product minus reactant, which is P minus R. Now, finally, this is an endothermic graph because P minus R results in a positive number. Now, if you remember our previous video about delta H's, we said that a positive H means it is endothermic. And now let's look at exothermic. Exothermic, as you might have expected, is just opposite. So over here we have our y-axis is potential energy again. Our x-axis is time. And as time increases, the amount of potential energy decreases. So this is products, this is reactants, this is our EA, and from here to here, here to here, this is delta H, and this is EA prime again, just like last time. Now over here, the heat delta H will be negative number because the product is a less number. The product is smaller than the reactants. So when you have a small number subtract a big number, you get a negative answer. So negative H's stand for exothermic. Now we're gonna talk about catalyst. So what happens when there's when you introduce a catalyst into the reaction? Well, let's take endothermic for example, right? It's gonna look like this. This is our original, and with the catalyst, it's gonna look like this. All right, the smaller one is gonna be the catalyst, and the taller one will be the normal. A catalyst's job is to decrease the activation energy, but the amount of energy that reactions and products start off and end with does not change. The only thing that changes is the activation energy. Thank you for watching.